my name is Christina Xing. I am a member of Dr. Lopez's Space Physics Research Group. My topic is a case study of pressure balance and the motion of magnetopause. I will be presenting observation from August 18, 2009, where the interplanetary magnetic field was directed southward. The action starts at 2020 Universal Time and continue until 2035 Universal Time on August 18, 2009. According to the magnetic field data presented in Figure 1A, THEMIS A was the first spacecraft crossed the magnetopause at 2021-20 Universal Time and stayed outside in the magnetosheath during the entire time. The southward magnetopause crossing can be verified when BZ values change sharply between positive and negative values due to inside of magnetic field is always positive in southward condition. If BZ value is negative, you know you cannot be inside the magnetosheath anymore. It has to be outside. Figure 1b shows at 2024-26 Universal Time, THEMIS A crossed the magnetopause, going from inside the magnetosphere to outside in the magnetosheath. At 30:49 Universal Time, it starts to go back out into magnetosheath. Figure 1c shows at 20:25-16 Universal Time, THEMIS E crossed the magnetopause, going from inside the magnetosphere to outside in the magnetosheath. At 20:29-35 Universal Time, it starts to go back out into the magnetosheath. The THEMIS spacecraft A, D, and E were all on the day side of magnetosphere, going out into the magnetosheath on August 18, 2009. Figure 2, which is the opposite plots, featuring the X component, Y component, and Z component, and provides the approximate location of magnetopause during a particular 10 minutes time period. Now let's move to Figure 3a, the density plot of THEMIS A, D, and E, where THEMIS A in red, THEMIS D in green, and THEMIS E in blue. As we can see, the time matches with the magnetic field data. The sudden increase of the iron density represents the satellite going out into the magnetosheath. In the magnetosheath is the compressed solar wind approaching Earth, but all of a sudden very slow, higher density of plasma in magnetosheath. The plasma density in the magnetosheath is so much higher than it is in the magnetosphere, and that's when we see those sudden jumps. It is an indication of the satellite crossing into the magnetosheath, and that's how we identify magnetopause crossing. Figure 3b, the iron total pressure plots, matches with the iron density plots. As we can see at 2031 and 2032, both THEMIS D and the E start to go back out, but don't go all the way out and then comes back in. To calculate the speed of magnetopause motion, I have examined all the activities between 2020 Universal Time and 2035 Universal Time. A summary of all magnetopause crossing is presented in Figure 4. Each dots indicating a magnetopause crossing happening, which help us to determine the magnetopause motion. As we can see, THEMIS A saw the magnetopause at 12.3 Earth radius, while THEMIS D and THEMIS E saw the magnetopause was a lot further in at 11.5 Earth radius. Lastly, in Figure 5, I present the speed of magnetopause motion. Each set crossing that involves two spacecraft. The velocity was how far apart each spacecraft were between a time when they saw the magnetopause. During the period, we have examined the typical magnetopause speed in X direction. Average speed of magnetopause between THEMIS A and D was 60 kilometers per second. Between THEMIS D and E was 84 kilometers per second. And between THEMIS E and D was 57 kilometers per second. And average pressure balance is consistent with the average motion magnetopause position. So for future work, we will run simulation of this event, and by using input from THEMIS D and THEMIS C, since they are nicely aligned, and see what's happening in the solar wind and magnetosphere. Thank you. Have a great day.